In this lecture, we're going to add a new feature to the home page called infinite scrolling. Currently, we're displaying the entire set of results from Firebase. This solution is not scalable if we end up having hundreds of songs. The user will experience severe lag the larger the dataset is. It would be wiser to change this behavior by requesting the list of songs in smaller pieces. We can use a technique called infinite scrolling to enable this behavior. Infinite scrolling works by requesting additional data if a user scrolls past a specific location on the page. As long as the user is scrolling, the list will continue to grow. There are a couple of things we need to think of when implementing infinite scrolling. Firstly, we need to decide when to perform a request for more songs. If a user scrolls past a location on the page, we'll want to begin requesting data. This is where things can get tricky. We need to keep track of the last set of records we requested. We don't want to return a list of songs that have already been requested. Secondly, we want to make sure we're not making multiple requests. It can lead to inconsistent results and increase the load on the server. We'll address these issues when we come across them. Let's start by outsourcing the request to a separate function. Open the home component file in your editor. Inside this component, we're requesting the data in the created lifecycle function. We'll be performing a similar request when the user scrolls to the bottom of the page. It would be a good idea to move this code into a method we can call repeatedly. This way, we can reuse it to send requests. Below the created function, we'll add the methods object to the component's options. Inside the methods object, we'll define a method called getSongs. We'll add the async keyword to the function because we'll be performing asynchronous tasks. Next, we'll cut and paste the contents of the created lifecycle function to the getSongs function. This function will need to be called from the created lifecycle function. We want to make sure we're making a request for the list of songs when the user first lands on the page. We'll get the same result we had before. The main difference is that we're outsourcing the request to a method we can recall. Great. The next thing we'll work on is detecting when the user scrolls the page. We want to request more data when the user has scrolled to the bottom of the page. After calling the getSongs function in the created lifecycle hook, we'll call the window.addEventListener function. The name of the event we want to listen to is called scroll. The scroll event is emitted whenever the user scrolls. We're listening for this event on the window object. If this event is emitted, we'll run a function called this.handleScroll. We have the option of using an anonymous function. However, we want to remove the event, otherwise we'll experience memory leak issues. First, before we remove the event listener, we'll define this function in the methods object. This function will be responsible for checking the current scroll position of the page. We'll be writing the logic in a moment. Let's remove the event listener if the user navigates away from the page. Components are unmounted if the user navigates to a different page. In the components options, we'll define the beforeUnmount lifecycle function. The beforeUnmount function is called before the component is unmounted. We're using this lifecycle function because we want to remove the event listener. We could have used the unmounted lifecycle function, but that can cause issues. We need to reference the handleScroll function if we want to remove an event listener. We won't be able to if the component is already unmounted. In the function, we'll call the window.removeEventListener function. We'll pass in the same values we used in the created lifecycle function. Removing the event listener is always an important step if you're working with the event system outside of Vue. We can move on to handling the scroll event. We're going to need some information about the user's browser. In this image, the purple box represents the entire page. The green box represents the viewable area in the browser. There are three properties we're going to need to check if the user is scrolled to the bottom of the page. The first property is called offset height. This property contains the height of the entire page. For this example, let's assume the height of the document is 2000 pixels. The second property is called inner height. This property contains the height of the viewable area in the browser. It's how much of the page the user is able to see. For this example, let's assume the height of the viewable area is 600 pixels. The last property is called scroll top. This property contains the distance from the top of the page to the top of the viewable area. In this example, it's clear the user is at the bottom of the page. This will mean the scroll top property should be 1400 pixels. Here's what we'll do. We'll add the inner height and scroll top properties together. If sum is equal to the offset height property value, we'll send a request for more songs. We'll be working in the handle scroll function. We're going to destructure the document.document element object. This object will contain two of the properties we need. They're the scroll top and offset height properties. Next, we'll destructure the window object. We'll grab the inner height property from it. It's not necessary to destructure the properties. I recommend it for readability. The next thing we'll do is check if the scroll top and inner height properties are equal to the offset height property. We'll declare a variable called bottom of window. Its value will be the following: math.round scroll top plus inner height equals offset height. We're wrapping the scroll top property with the math function. This property may have decimal values. We want to be dealing with whole numbers when making the comparison because the inner height property will always be a whole number. The value of this variable will be a Boolean value. Below the variables, we'll create a conditional statement. We're going to check if the bottom of window variable is truthy. If it is, we'll log a message in the console. This function we've written will be able to tell our component to request more data if the user scrolls to the very bottom of the page. If we did everything right, we should be able to see the message logged in the console. Let's view the home page in the browser. If I scroll to the bottom of the page, we'll find the message we logged in the console. This message verifies we're able to detect when the user has scrolled to the bottom of the page. We can proceed to make a request. We'll take care of this in the next lecture.